Okay, hello everyone. Welcome to today's Python lesson. Today we're going to be creating a 2048 game. Okay, so for those of you who haven't played 2048 before, we're basically going to implement a 2D sliding block puzzle game where the blocks with numbers are combined to add their values. So right here I have the link to their website. So we can just play around with this to get a sense of the rules so that we can make our own version today in Python. So how you play is you can use your arrow keys to combine. You can go up, down, left, or right. And it's kind of hard to see my controls. So for example, if I do up right now, the twos will combine. And if I do up again, the fours will combine. So two adjacent numbers will combine in the direction that you're moving, and then all the blocks in that row or column will slide to that side. And then the objective is to add up the blocks up to 2048. And then you lose when all the blocks are filled with numbers and there's no more valid move you can make. So basically, if you're stuck, you lose. Okay, so now let's like formally take a look at the rules here so that we know how to implement our own version and try to follow these rules. So the rules are kind of self-explanatory, but on each turn you have to choose a direction. So this could be up, down, left, or right. And it'll be probably easiest to implement this using like WASD inside of Python, since with the input function instead of the arrow keys. And the next rule is that all the tiles will move as far as possible in that direction, and some tiles will move more than others. So only the two adjacent tiles in that direction with matching numbers can combine. And when they combine, the new number is going to be the sum of those previous two numbers. But since we know that the two numbers are the same, you can just multiply by 2. So we're going to do that later when we implement the code. And the move is only valid when at least one tile can be moved. So if nothing in that direction will move, that move will be considered invalid, although this isn't really important because if you do a move and let's say the game is not over, but you move in a certain direction, but nothing moves, because they're already all like attached to that side of the board, let's say, then you don't really have to consider like saying it's an invalid move since nothing will just happen. You can just go again. So we'll get a chance to visualize this later. Um, and then a new tile is spawned at the end of each turn at a randomly chosen empty square, if there is an empty square. So if it's possible that there's no empty squares, but you still haven't lost yet, in that case, you still have two adjacent ones that can be merged. And the next rule is kind of interesting, which says that most of the time a 2 is the new tile that is going to be added, but occasionally it's going to be a 4. So according to the rules, 90% of the time, the new tile that is spawned will be a 2, and the remaining 10% of the time, it will be a 4. So we can just implement this logic using random in Python. And then in order to win, you must create a tile with the number 2048, and you lose if there are no valid moves possible. And it's also it's also worth noting that you start with 2 tiles. And these tiles are also randomly generated, and they follow this 90% rule. So 90% of the time it's a 2, and the remaining 10% it's a 4. So does anyone have any questions on the rules of the game? Okay, if not, then let's go ahead and just create a new file. Okay, so take a moment to create a new file in whatever editor you're using. Okay, so let's first create some of the basic um, helper functions that we'll need for this game. So the first one is we're going to need a print board function. So yeah, by the way, we're going to be coding this in the terminal. So you're going to play in the terminal only. Um, if you want to make like a interface, like a visual, like graphic user interface, we'll have to use like additional libraries for that. So maybe we can do that in the future. But today we're just going to be doing it in the terminal. So the print board function is kind of annoying. I already have it written out and I don't want you guys to write this because it's just a lot of dashes and stuff in order to print out the 4x4 board. So I'll just give this code to you guys in the chat. So yeah, I can show you guys how this would look like. And then so for the real game, we will start with an empty board. So in the real 2048 game, um, when the tile is empty, there's no number that shows up. But in order to make the math, like the addition, more convenient for us, we're gonna set we're gonna set empty we're gonna set the tiles to 0. So we're just gonna start by creating an empty 4x4 um, table. Okay. So we can run the print board function to see what this would look like. Oops. Okay, so we just have an empty 4x4 grid. So you might notice like the grids are not exactly a square, and that's because when you have longer numbers, for example, like 128 or something, then if you do a square, it's not going to have enough room. So that's why I have a lot of empty spaces here. And then another thing which kind of makes this super annoying is that you can have numbers that are of different lengths. So for example, like 2 is only 1 digit, but then if you have something like 16, that's 2 digits. But if you still want the table to look aligned, like these vertical bars to be the same, then you actually have to calculate how many additional spaces you have to print in between. So that's why I have the length of the number, or you can just think of it as the number of digits. So I just converted the number into a string and then got the length of it. And then, so this in total is going to be 8 spaces. So if your length is 2, for example, you just have to print 6 additional spaces. So that's what this code means. We're just going to print as many empty spaces as needed to fill these up so that all numbers, no matter how many digits they have, it's gonna look the same. So for example, if we just like added some random numbers, you can see um, that it would still be aligned. I'm gonna put it back to 0. Okay, so that's gonna be the print board function. So now let's create a new function called generate new tile. Okay, so what this function will do is it will first pick random open okay. Pick random open space. And then it will determine if the tile is 2 or 4. So we said earlier, 90% of time it's a 2, and then the other 10% of the time it's a 4. Okay, so take a moment to try to implement this function yourself. Okay, does anyone need more time? Okay, if not, then let's figure this one out. So let's first decide what the tile number is going to be. So we said it's going to be 2 90% of the time. So we can say it's going to be 2 if so we can do random.randint 0 to 9. So this will generate a number from 0 to 9 inclusive, I believe. Okay, we did not import random yet. Okay, and if this is less than 8, then it will tell us this is 90% of the time. And otherwise, it's going to be 4. Okay, so now that we have our number, we have to make sure that we have to find an empty space. So we can do, so here we need to kind of validate if that square is available or not. So we need a while loop, and then we will then generate the indices of the cell we want. And then if this is 0, then it means it's an empty cell, so we can just place the number there and then break. Okay, does anyone have any questions? Okay, I think this should be a 9 since it includes both endpoints. So if we want 9 out of 10 times, it's going to be a 2, then this should be 0 to 8. So we should do less than 9. Okay, so next let's create a setup function. This one, we said in the beginning of the game, we just want to generate 2 tiles. So we can just generate it twice. So we can just call that function that we just created twice. Okay, so before we implement the actual logic of the game, which involves the adding and the sliding, since that part is the most difficult part, let's first create the other functions we need. So we need to create a function to check if the game is over. Okay, does anyone have any ideas about how we can do this? Okay, so Chow is saying we can create the shift functions first, and then if all, so I think you're saying if we cannot shift it in any of the four directions, then it's game over. Is that what you mean?
I'm thinking of it as sifting, kind of. It's fine. It's same thing.
Okay. So yeah, actually we don't need to have that part first in order to check if it's game over. So an easier way is we can just check if there are two adjacent tiles anywhere. And if there are, then the game is not over. And then we also know that if it's if there are empty tiles, then it's the game isn't over yet. So let's first create a function to check if the board is empty, since we'll use this later on. So this one should be pretty straightforward. So we can just loop through the entire board. And if there is a tile that is zero, then we okay, if there is a zero, that means there is an empty tile. Okay, so I think this is wrong. I think we return false since we're checking if it's empty. And then if there isn't a single zero, then it is empty. Okay. So now let's create the function for checking if the game is over. So if there is empty, like if there is a tile in the board that is empty, then the game is definitely not over since we can still generate new tiles. So we can just return false right there. Okay, so like I said earlier, we need to check if there are adjacent tiles that are identical. So let's first check the row, and then let's do column after that. Okay, so take a moment to write the code for this, and if you have any questions, you can feel free to unmute or ask in the chat. Yeah.
No, wait, it shouldn't be is full because it should be if the board is full. If you want is empty, it should be like, are there empty tile, empty spots exist? Shouldn't be is empty because that implies that we're checking if the board is empty, not if the board is full.
Okay, yeah, I agree. I kind of named this function kind of poorly. So, anyways, what I want this to do is to check if there are empty tiles in the board. So I guess we can rename it to is empty um are empty tiles. I'm trying to think of a better name for this. Is empty tile exist or something? Okay, I'll keep that name for now, but does this clarify it a bit? Okay, then let's keep this for now, and if I can think of a better name, then I'll change it again. Okay. Okay, so everyone understands what they're supposed to be doing for this. We're just checking if there are two tiles that are identical. So if there are, then we can return false since the game is not over, since they can still combine those tiles. But if there isn't any adjacent tiles that are the same, then in the very end we can return true. Okay, so I'm gonna turn off the auto code complete AI feature because it was making a lot of mistakes just then, and it's also kind of annoying. So I think you can turn it off in settings. I'll keep this one. I just don't want the inline completions. Hey, does anyone need more time? Or does anyone need help implementing this? Okay, well, if not, then let's go ahead and see. Okay, so let's first check if there are identical tiles in a row. Okay, so what this means is like if there's a 2 here and there's a 2 here, then this counts as two adjacent tiles that are identical in a row. But if we had a 2 and a 4, then this wouldn't be considered identical adjacent cells. So we're only going to check rows first, and then we're going to do columns. Okay, so we have to loop through each row, and then we're going to compare every two adjacent cells. So like this. Okay, so what that would look like is, so for I in range 4, so this loops through the 4 rows, and then so now we have to loop through the items in each column. So for J in range. And note this only has to be 3 since like I showed just then, oops. So we only have to check 3 adjacent cells. Does that make sense? So this will only need to be 3. And then so we're gonna check board IJ with the next one, which is board board I J plus 1. So if these are equal, then we can return false. Since if there are 2 adjacent ones that are equal, then the game is not over because you can still merge them together on the next move, technically. So that's it for row. So now let's work on column. So let's draw this out. Okay. Yeah, so now we're gonna have to check like all 4 of these columns. So for that, we could just switch the I and the J. So for J in range 4. And then now it's going to be for I in range 3. So now we have to check these 3. So that would be if board sub I and J equals board I plus 1 and J. Since I is vertical and J is horizontal, since we're checking vertically, then we should be adding I. So note the difference between these two. And then after that, we can return false. And if there are no adjacent tiles that are the same and the whole board is filled, we would already know that, then we can return true. So the game would be over in this case. Okay, does anyone have any questions on this? Okay, so now let's code the most important part and also the hardest part, which is each turn. Well, at least the first part is going to be easy. We're just gonna ask the user to type in WASD. So let's do move equals input enter move. And then let's make this lowercase just so that when we check if move is WAS or D, we only have to consider one case. So if they didn't type in WAS or D, then we have to ask them to do it again because they entered something that is not correct. So if it's not W and it's not A and it's not S and it's not D, then let's ask them to type it in again. So let's say invalid move, enter move, and make this lowercase. Okay, so after the while loop, we should get either WAS or D. Okay, so now we're gonna have to write two separate if statements. So let me just write that out first. And then we'll fill in the body of those. And then you can do else right here, but just so we know what it is, let's say D. Okay. So let's think about the logic for adding and sliding the cells. So I would encourage you all to go to the 2048 game and then try out a few moves to see if you notice any patterns. Okay, so for example, in this situation, if I move up, then these top two tiles that are both twos should combine into a single four, right? So let me draw that out here. Like so, let me use a different color. So we would end up with a single four over here. And then this two down here would slide here. And notice how these are the ones being added together and not these. And this isn't due to the fact that these are closer together and these have a space between. That's not the reason for why we add these two together. It's because since our move is up, it will always first add the ones that are highest, that are closest to the top. And if you think about this in terms of like the physics of the game, that's just how it works. Since basically we're trying to slide everything up, the ones at the top will be the first to get pushed together. So imagine like we're trying to push all the tiles together. Since we're pushing it into the wall on this side, it, things on top are always going to get added first before these two. So in fact, these two won't get added at all because this would just turn into a four and then this would disappear and then the two would have nothing left to be added. So it will just simply slide here. Okay, so let's look at a few more examples. Okay, so in this case, if you moved up again, it would be kind of straightforward. These two would just get added. Okay, so this is also easy. If we move left, the twos will just get added and then so forth. So let's try to look at another case. Trying to find a good case here. Okay, so here's a good example. So if we slide to the right in this situation, like what I said earlier, these two would be added together. So these would turn into a single 4 over here. And then this would go bye-bye. So in the end, it would look like 0. So 0 is for empty. 0, 4, 2, 4. So that's what the top row would look like after the move if we were to slide right. So it would look like 4, 2, 4 instead of 4, 4, 2. So 4, 4, 2 is not what we would get. So if we added these two first, we would get 4, 4, 2. But to confirm what I said earlier, let's just see if we get 4, 2, 4, which is what we're supposed to get. So yeah, right here we have 4, 2, 4. Let's look at some more examples. So if we slide down, same thing, we get 4, 2, 4 in this case. And then if we look at the first column, it's kind of obvious, but nothing will happen because there are no two adjacent ones. So when we think about the logic, this is also very similar to checking adjacent cells to see if they're the same. But there is a very important thing to note right here. If we were to slide right, well, from common sense, we would know we would end up with a 4 over here. But if we were to check adjacent cells, you would notice that there are no adjacent cells that are the same because even though these would add, they're separated by a 0 in the middle. Okay, so we have to consider the case when when we have two of the same numbers that are separated by empty spaces. So this could be like 2, 0, 2, 0, like we have in this situation. Remember, we said that empty ones are zeros just to make our calculations easier. And like we could put an empty string there if that makes you happier, but since we're just dealing with only numbers here. And same thing if we have 2, 0, 0, 2. Both of these would transform into 0, 0, 0, 4. The first one is they're separated by one empty tile. The second case is they're separated by two empty tiles. So both of these cases, we would end up with this. Okay, so does anyone have any ideas about how we can get around this situation of having like zeros in between? Well, one way you can think about it is let's just remove the 0 and make our lives easier. So that's what we're going to try to do. We're going to take out the zeros in each row or column. Okay, so let's work on the W case first. So W is up. Okay, so when we're moving up, are we dealing with rows or columns? Okay, you can feel free to say the answer. So when we're moving up, are we sliding things within each row or within each column? Yeah, so column is correct. So when we're moving up, like we're dealing with each individual column. So the outer loop, we're just going to loop through each column, and then within each column, although I said we're dealing with columns, we're actually dealing with rows because these are separate rows inside of a column. So it's kind of tricky. Okay, but we're going to loop through the, the horizontal way first. So that would be I. Okay, so for I in range 4. So like I said earlier, we're going to remove all the zeros inside of each column. So let's make a new column without the zeros. So let's first start with an empty column. So now let's construct our new column without zeros. So let's do for okay, wait, sorry. This should be J since horizontal is J. So now we're going to go through each column. So this is for I. For I in range 4, if it's not a 0, we'll add it to our new column. So if for ij is not 0, let's make sure to define our global variable first so that we can access board inside of this function. If, oops, I forgot the code. If it's not 0, then let's add it, let's append it to the board. So after that, we should have our new, our new column without zeros. So now let's first add and then we'll combine. So now let's look here again. Okay, so let's just look at this example right here. Let's say we're moving up. So we have 2, 8, 4, 4. So we know our end result should be 2, 8, 8, right? Okay, so in this case, there's no zeros, but for zeros, it would be the same since we just take out the zeros, since we just took out the zeros. So when we're moving up, we should always check from top to bottom since cells that are higher will get added first. So the logic would be, let's first start with these two. Is 2 equal to 8? Since they're not, then nothing happens. And then is 8 equal to 4? Since they're not equal, nothing happens. And then lastly, is 4 equal to 4? Yes, they are equal. So 4, 4 should turn into 8. It should turn into 8, 0, precisely. So we're gonna keep the new one in the highest tile. And then, okay, so basically when we have 4, 4, the 4 should double, and then the 4 that is further down should turn into a 0. So that's the logic. And since we removed all the zeros, we don't need to consider the case if we have like 2 4s that were originally like had a space in between, since we transformed it so that there's no more zeros. Okay, so let's see what that would look like. Okay, so I'm gonna go back just for a second. So note that we're only making 3 comparisons once again. So it should be the length minus 1. But it's not necessarily going to be 3. Since we removed the zeros, we actually don't know exactly what the length of the column is. So we can't hard code a value in this case. We actually have to get the length of the column, the new column that is without the zeros. So for I in range, the length of the new column without the zeros minus 1. So now this logic will be kind of similar to before. If column I is equal to column I plus 1, then what did we say earlier? We said the first one was going to double. So the one higher will double. So when I say higher, it's like the position on the board physically is higher. So you might be thinking I plus 1 is higher than I, but it's the one. But here actually like this is I and this is I plus 1. I'll write it here. This is I and this is I plus 1. So this one is the one that should double, so it would turn into an 8, and this one should be 0. So I should double, I plus 1 should always turn into a 0. So I will double, so times equals 2, and then I plus 1 will turn into a 0. Oh, and then for fun, if you wanted to implement a score, you'll see up here that there's a score. So let's create a variable called score equals 0. So let's do global score up here. I didn't include this in the rules, but how the score works is that your score will increase by the sum. So in that case, it will increase by 8. So it's technically the same as call I plus 1 now. Okay, so that was just only the code for adding it. But now we have to actually slide it to the top. Okay, so let's consider how to slide it. So let me create a new example. So for example, let's say we started with 224. This is the column we had after taking out the zeros. So after we run the code for that we already written just now, we would get 404. So now our goal is to try to okay. So now this is interesting because I forgot the rule exactly, but this doesn't turn into an 8, I think. You can't double add. Yeah, that's the rule. You can't double add. So you cannot turn this into like 800. You can only go through and add once. So let's say after we added the 2 and the 2 over here, we got a 4 and another 4. You cannot add them again since your move is over. So after you just add once, you have to combine immediately. So now our goal is 800. Does that make sense? Our goal is to transform this into, or we can slide it into 800. Wait, no. Sorry. The goal is to transform this into 440 or just 44. Um, I just said you can't add it again. So we want to get rid of this 0. So now this code is going to be very similar again. We have to remove the zeros again. Even though we already removed the zeros in the very beginning, it's possible that you'll create new zeros after adding them. So we need to remove the zeros again. And then Chow made a good point, which is after you remove the zeros, you need to add zeros back to the end, though, to the end. So our new column should be 4400 if our original column was 2240. So we remove the 0, so we get 440, but this is not a complete column. We need to add a new 0 at the very end. Okay, so let's first work on removing the zeros. So let's create a new column. We need to create a new variable here for new column. And then, so this logic will be very similar. Let's say for num and col, if the number is not 0, we'll add it to the new column. So that way we're skipping all the zeros. Okay, let's add a comment here. And then this is add. So now add zeros to the end. So we don't know how many zeros we need to add. So let's just do a while loop here. So while the length of this new column is less than 4, we will add a 0. Okay, but we were doing all of this in a new column. So now in the very end, we need to add all this back to the original board. So let's do for I in range 4, and then so we need to set it to the board. So the board ij equals new column I. Okay, so this might also be kind of confusing. So don't worry about the J because we know the J is on the outside. So J is just specifying which column we're in, but the key is that the ith row, since new column is a one-dimensional list, so we just set it to the I. So this I will line up with this I over here. Okay, so we are done for just W. Okay, let's delete that. So now this is complete. So we just finished W. Hey, does anyone have any questions on how this works? Okay. If not, then we'll continue this next week. But if you want to take a look at the code, I'll just post the GitHub link so you can view the code there. It's in the chat now. So yeah, we'll stop here today. And you can stay behind if you have any questions. But thank you all for coming today.
Right. This is more of a suggestion, but I think that you should like have it shift vertically and then you can toggle the direction instead of coding for up, down, left, and right.
You mean like just only do horizontal and vertical?
Yeah, like horizontal and vertical, and then have like you can like have two modes, like horizontal and vertical, but you can like toggle, but you can like also if it's going right up or left down. It's like let's code.
Yeah, so you can write only two cases, which is vertical and horizontal. But you can actually even do just one case, but those are kind of more complicated. They require you to like extract a single row or column, and then depending on if it's up or down, you have to reverse that row or column as well. So it's kind of
Yeah,
complicated. I just wanted to do four separate cases just to show you guys the logic. I think, yeah, understanding the logic is most important for this
right.
project. But you can definitely combine those cases. You'll just have to like reverse the column if you're doing up and down. So yeah.
Thanks. I have to go. Goodbye.
Hey, any other questions? Okay, if not, then we'll see you next week. Okay. Thank you, everyone.